So we're looking at the limit as x goes to 0 of x squared cotangent 2x times cosecant of 3x. And what I would do first is I would change these functions, cotangent and cosecant, into ones that we're more familiar with, like sine and cosine. So I would rewrite cotangent of 2x as, well, that's cosine over sine, so that would be cosine 2x over sine 2x. And then cosecant is 1 over sine. So times 1 over sine of 3x. And then we have this x squared in front, limit as x goes to 0. Okay, so now we've substituted like the pieces that we know more of how to deal with. And what I want to do next is do something with this x squared. So I know we can do something with like sine x over x or x over sine x. So the limit that we're looking to create, if we can, is we're looking to either make the limit as x goes to 0 of x over sine x, which is 1, or we're looking to make limit x goes to 0 of sine x over x, which is also 1. But what really needs to happen is whatever the argument of the sine is needs to match exactly with what's on the other side of the fraction. Same thing in this case, whatever is within the sign needs to be exactly what's on the opposite side of the fraction. So I know that we're going to need an x somewhere, but we have an x squared right now. But we also have two sine functions. So I'm now going to change this to the limit as x goes to 0 of x cos 2x over sine 2x times x over sine 3x. So all that happened there is this x squared is really x times x, so I put one of the x's with this quotient and one with this over here. So I just split up x squared into x times x, but split up the x's into these different fractions. So it's just a rewriting of what was there before. And now, if we look at this argument of the sine, well, first, we don't really care about what's happening with the cosine as x goes to 0, because that's just going to be cos of 0, which is 1. So we're not really worried about that. So you know what? I'm actually going to move that. The cos 2x, I'm just going to put it at the end. So just here at the end, I'm just going to say multiplied by cos 2x. Okay, so I just moved it to the end there, just because we're not too worried about it. And now we're trying to create that sine of something over that thing within the sine. So if you look here, we have a 2x within the sine. So what that means is that we need a 2x on the top of the fraction here, but we don't have that right now. So we have to create it. So what we're going to do is we're going to go ahead and multiply by 2 up there on the top of the fraction so that we have 2x to match sine of 2x, except if we multiply by 2 on the top of the fraction, then we have to multiply 2 on the bottom, because that's like multiplying by 2 over 2, which is like multiplying by 1, so that doesn't change our fraction at all. And then same thing with this second fraction. So here our argument is 3x, so we need a 3x on top to match that. Well, that means that we need a 3 on the bottom as well, because that's like multiplying by 3 over 3. Okay, so now as we actually go to evaluate like each of these pieces of this limit. The product rule says that if the limit of each part exists of a product, then you can find the product of the limits. So I'm going to write it out like that. So we have the limit x goes to 0 of 2x over 2 sine of 2x times the limit as x goes to 0 of 3x over 3 sine of 3x, and then times the limit as x goes to 0 of cos 2x. And then let's evaluate all those pieces. So this first limit piece, the limit x goes to 0 of 2x over sine 2x is 1. So all we're going to have here is the fraction 1/2 because of this leftover 2 on the bottom, times 1 because that's that limit. So this first piece here is just going to evaluate to 1/2. Okay. And then this second piece, limit as x goes to 0 of 3x over sine 3x is also going to be 1, and then we have this leftover 3 in the denominator, so that one's going to evaluate to 1/3. Okay, and then this last limit here, if we plug that in, that's going to be cos of 0, which is equal to 1, so multiplied by 1 at the end. So our limit is going to be 1/2 times 1/3 times 1, so it's just going to be 1/6. Okay, but we really need to split up the limit into these different parts to be able to handle it, to evaluate it. And really the important idea here is with the sign law for limits, we have to have the exact same thing inside the sign as on the opposite side. So if we don't have that, then we have to create it by multiplying by something. So here, that's why we multiplied by 2 over 2 to get the 2x on top. Okay.